Hi everybody, myself Vinod Pandey. In association with finance classes, we have taken an initiative to cater to the academical need of the student. In that context, we are going to launch certain videos which will be catering to the MCQs based on different topics which are necessary for your JEE main. In that case, we are going to take up only those questions which are more likely to be asked in your competitive exams. So let us begin with that. We are going to deal with 10 most important MCQs which are more likely to be asked in your JEE main this year. So let's begin with the most important question, most likely question which might be asked for your competitive exam this year. So now, the first question to you people, the homopolymer formed from 4-hydroxybutanoic acid is. So these are the 4 options given to you and you have to select the one which is a correct answer. Now how will you go about with the solution part? How will you go about with the solution part? First and foremost, what is 4-hydroxybutanoic acid? When I say 4-hydroxybutanoic acid, butanoic acid, that means 4 carbon with carboxylic group here. Okay, so carbon, we fill up the hydrogen. This is your 4-hydroxybutanoic acid. This OH, you can write it in this manner also. So this is your 4-hydroxybutanoic acid. And now you want homopolymer. To get a homopolymer, what you need to do is just remove water from this. Just remove water from this and you get your polymer. You get your answer. For that, always remember OH comes out from the acid and H comes out from OH group. Now, if I write it in a condensed form, this is CH2 thrice C double bond O. So this is the homopolymer. So this is the answer. Now look at the option. It is matching with A. So your answer is A for this question. Okay, so this is your first important question. You must be wondering, this is so easy. Yes, it is simple, and such type of questions are asked in your competitive exams. Okay, so this is your first question. Let's go to see the second question now. Okay, so let's see the second question now. Potassium mercury iodide. This is called Nessler's reagent. Is 40% ionized in aqueous solution. The value of its Vent-Hoff factor is. Now we all know Vent-Hoff factor is I is equal to 1 minus alpha plus n alpha, where alpha stands for degree of dissociation and it is given 40%. So alpha percentage is given as 40%. 40%. Now, therefore, alpha will be 0.4. Alpha is 0.4. What is n then? N factor. We all know Nessler's reagent, that is K2HgI4, is a coordinate complex compound which dissociate to give you 2 potassium ion and 1 complex ion Hg(I4) minus 2. Okay, so now total number of ions are 3. 2 plus 1, 3. So n value is 3. Substituting this value here, so I will be equal to 1 minus alpha is 0.4 plus 3 into 0.4. So your I will be, after solving this, it is 1.8. So the answer for this question is A. The answer for this question is A. Okay. Now we go for the next question. Now the correct option with respect to the Pauling's electronegativity value of the element is. Now out of this option, which is your answer? Electronegativity. We all know that as atomic size and electronegativity are inversely proportional. Electronegativity are inversely proportional. That means as the size will decrease, electronegativity should increase. Now, if you see very carefully, they have indicated various groups. Group 13 elements are there, group 14 elements is there, and group 15, even group 16 elements are there here. Now group 15, now if you see group 15, boron, group 13, boron, aluminium, gallium, indium, thallium can be remembered as bangan, aloo, gobi in thali. These are the elements of group 13. Carbon, silicon, germanium, tin and lead are the element of group 14. Corruption से गई सरकार पीछे. So you can remember in this order. Group 14. Nitrogen family. Nitrogen, phosphorus, arsenic, antimony, bismuth can be remembered as nalayak, pagal, alshi, sharabi, battamiz is group 15 elements. Oxygen family, oxygen, sulfur, silarium, tellurium, polonium, on special service, traffic police. So you can remember all these elements. Now, as we know, as we go across the periodic table, the size decreases. Across the period, size will decrease. If size decreases, electronegativity will increase. Now look at the option. Silicon and aluminium. Is electronegativity of aluminium greater than silicon? No, because it is silicon which will be greater than this aluminium. What about gallium and germanium? Yes, can you see here? As we go across the periodic table, electronegativity increases. Yes. So your answer for this question is B. If you see the other option, sulfur and phosphorus. But in this case, sulfur and phosphorus, the electronegativity, sign ulta jana ji, sign should be above. Sign should be, okay, the options of silarium and tellurium. Silarium here, tellurium here. Okay, so this should not be sulfur, it should be phosphorus with silicon. Okay, so in this case, phosphorus electronegativity will be more than silicon. So the options here will be B, which is the correct option. Okay, so there should be no sulfur here, because if sulfur comes here, then you have two options. You will have B as well as C. Both the options are correct then. But right now, if you see silicon, will have less electronegativity than phosphorus. So this is question number 3. Question number 3, your answer for this question is B, which is the correct answer. Okay, let's see question number 4 now. In case of question number 4, the hydride that is not electron deficient, the hydride that is not electron deficient is A, BH3, aluminium hydride, C, silicon hydride, or D, gallium hydride. So let's see the solution part for this. So the hydride that is not electron deficient is, let's take BH3 first. Boron. Boron has 3 electrons in its outermost shell because its atomic number is 5. So 3 electrons in its outermost shell. One it is sharing with hydrogen. So in this case, boron has 6 electrons in its outermost shell. So it has a deficiency of 2. 2 electrons required, 1 pair is required. So this cannot be your answer. What about aluminium hydride? The same way. Aluminium's atomic number is 13. This also has 3 electrons in its outermost shell. So aluminium also is electron deficient. And the one which is electron deficient, they are called Lewis acid. So they are Lewis acid, or also called electrophiles. So these 2 are electrophiles. What about silicon hydride? Oh, silicon has 4 electrons in its outermost shell. It has 4 electrons in its outermost shell, and 4 electrons are shared by hydrogen. Total comes to 8. So it does not have electron deficiency. So your answer for this is C. Gallium hydride also has a deficiency of electron. Okay, so your answer for this question is C, where all the electrons total makes up 8, which is not electron deficient. So this is question number 4 for you. Let's go to see now question number 5. Now look at this question. Propane 1-ol can be converted to butanoic acid by the following sequence of steps. Which is the correct steps? Which is the correct answer for this? Now when we start with propane 1-ol, I want to convert it to butanoic acid. I want to increase 1 carbon. Whenever you want to increase 1 carbon, you need to take potassium cyanide, KCN. It has to pass through cyanide. So what I am going to do is, let's check it out with the first option. If I treat it with potassium bromide, PBr3, this OH will be replaced by bromide. So we'll get CH3, CH2, CH2Br. That is 1 bromopropane. After this, if I treat it with alcoholic potassium cyanide, this Br will be replaced by Cn. So you will get CH3, CH2, CH2, Cn. Okay, that is propyl cyanide we get. Now you can do hydrolysis acidic hydrolysis. And the moment you do cyanide hydrolysis, acetic hydrolysis, you will get butanoic acid. So option A itself is correct. Option A itself is correct. Okay, so this is question number 5 for you people. Question number 6 is the electrode potentials for Cu2 plus 2 plus electron is giving you Cu plus, and Cu plus 1 plus electron giving you Cu solid, are 0.15 volt and plus 0.50 volt respectively. The value of E naught Cu2 plus 2 Cu will be A 0.10 volt, B 0.500 volt, C 0.325 volt, or D 0.650 volt. Now, how will you solve this question? Solution. We know that delta G, that is change in Gibbs energy, is given as NFE, where E is the electrode potential, F is the Faraday, N is the number of moles of electron given out. Let's consider equation number 1. Which is given as Cu2 plus aqueous plus electron giving you Cu plus 1 aqueous. For this, the voltage given is 0.50 volt. 0.15 volt. So delta G1 for this equation will be, N value will be 1, N value is 1, so it is minus 1 into Faraday into what is the value of E here? It's given 0.15. So ultimately this is minus 0.15 F. This is for first equation. Now equation number 2 is Cu plus 1 plus electron giving you Cu, that is solid, aqueous. Okay, for this delta G2 will be equal to, the N value here is 1 again, so it is minus 1 into Faraday into, this time the value of electrode potential is 0.50 0.50 volt, which is 0.50 volt minus. Okay, so this much Faraday, this much Faraday. Okay, now the required equation for us, required equation is, I wanted Cu2 plus to Cu. That means Cu2 plus aqueous will accept 2 electrons and get converted into Cu. Cu solid. For this, delta G will be equal to minus 2F, for which I want the E value. I want the electrode potential value for this equation. I wanted E for this equation. Acha, how will you get this equation? If you see very carefully, equation 1 and equation 2, if you add these two equations, you will get the final equation, required equation. So therefore, delta G will be equal to, of the total, will be equal to delta G1 plus delta G2. That is minus 2Fe will be equal to minus 0.15 into Faraday minus 0.50 Faraday. Now what you need to do is, Faraday gets cancelled, so minus 2 E naught will be equal to, F get cancelled, so minus 0.15 and minus 0.5 makes up 0.65. Therefore, the final answer will be, E naught will be 0.65 divided by 2. The answer for question number 6, which we did, is 0.325 volt. Now we go for question number 7. The normality of 30 volume hydrogen peroxide is, options are 2.678 normal, B 5.336 normal, C 8.03 normal, or D 6.685 normal. Now, how to get the solution for this? Solution. For this, you just need to remember one straight away a statement, and that is 10 volume will always corresponds to 10 volume strength of H2O2 always corresponds to 30.36 grams per liter, which corresponds to 3.036%, which corresponds to 1.7 normal, which corresponds to 0.85 molar. Now look at the question. You are asked, find out the normality of 30 volume strength of H2O2. Okay, take the relationship. 10 volume strength corresponds to 1.7 normal, and they are asking for 30 volume strength. 30 volume strength, what is the normality? So now instead of multiplying it, directly round it up and take this as 2. Take this as 2. 0, 0 gets cancelled. So it is 3 into 2. 3 into 2, your answer comes round about near 6. So look at the option. Which option is coming closer to 6? Oh, the answer is B. B is coming closer to it. So your actual answer is 5.336 normal. Okay. So in this way, you can straight away looking at the question, you can get your answers. So this is question number 7. Now we move for question number 8. So let's go for question number 8 now. Indicates by bypassing excess of chlorine gas, bypassing excess of chlorine gas in boiling toluene, which one of the following compounds is exclusively formed? The options are A, Me stands for methyl group. Me stands for methyl. Option B, option C, or option D, okay. So is it option A, B, C or D? So let's see the solution part of this question. By passing excess of chlorine in boiling toluene. First of all, what is toluene? It is benzene ring with methyl group on the top. Methyl group. This is called methyl benzene. Okay. So methyl benzene is also known as toluene. Now to this you are passing excess of chlorine. Excess of chlorine. Now why I wrote 3 here, I will let you know. First and foremost, do remember, substitution reaction is going to take place here, but substitution of benzene is very difficult because benzene is very stable due to aromacity, resonance, so it is highly stable. So substituting the hydrogen of benzene is very difficult. It is easy to substitute the hydrogen of aliphatic compounds. Okay, so this 3 hydrogen will be removed and in that place Cl will go. So your answer for this question will be Cl will be replacing the hydrogen of this methyl group. Okay, and the 3 hydrogen will combine with the remaining 3 chlorine and forms HCl. So option number D is your correct option. Option D is your correct answer. This is question number 8. Question number 9 is what will be the pH what will be the pH of a 0.05 molar barium hydroxide solution? What will be the pH of 0.05 molar barium hydroxide solution? A 12, B 13, C 1, or D 12.96. So now, since we require pH, let's see the solution. First and foremost, this barium hydroxide in aqueous medium will dissociate to give you barium ion and 2 OH ion, OH minus ion. Now this concentration which is given for both the ions. So the concentration of OH will be 2 into 0.05. So OH concentration, we get it from there, and that will be 0.1, which can be written as 10 raised to minus 1. Now directly we cannot take out the pH. We need to take out first POH. POH is negative log to the base 10 of OH minus. OH minus. Substituting the values, so log of 10, 10 raised to minus 1. So your answer for POH will be 1. POH is 1. And we all know pH is 14 minus POH. 14 minus POH. That is 14 minus 1. So the final answer for pH is 13. So your option B is the correct option. So your answer is B for question number 9. Now we go for question number 10. Question number 10. The reaction MgO solid, magnesium oxide solid plus carbon solid forms magnesium solid plus carbon monoxide gas, for which change in enthalpy, standard change in enthalpy is given as plus 491.1 kilojoules per mole, and delta S, that is change in entropy is 198 joules per Kelvin per mole, is not feasible at 298 Kelvin. Temperature above which reaction will be feasible is, the option given are Options are A plus 1890.0 Kelvin, B 248.0.3 Kelvin, C 2040.5 Kelvin, or D 2380.5 Kelvin. Now we go for the solution of this question. It says the reaction for which delta H is given to us and delta S is given to us. They are asking for temperature. They are asking for temperature. Okay, and they want the reaction to be feasible. At which temperature? We know that temperature can be calculated as delta H, standard delta H, divided by entropy change. Entropy change. So change in enthalpy divided by change in entropy. So let us see now, and do remember delta H value is given in kilojoules. So you need to convert into joules per mole. For that you need to multiply by 1000. So delta H is given as 491.1 multiplied by 1000 to make it joules per mole. Okay, this is conversion into joules, divided by, so this is joules per mole. Okay, joules per mole. Okay, now delta S is given as 198 joules per Kelvin per mole. Okay, per Kelvin per mole. Now I want temperature. Okay, now rather than sitting and directly dividing it, why don't we take approximate value? Why don't we take approximate value? Okay, so what I will do is, I will round it up this part. I will round it to 500. 491.1, I rounded it to 500 into 1000 divided by this, I rounded up to 200. Okay, now just see approximation. So this and this will get cancelled. 2 5s are. So our calculation becomes easy. So it is 500 into 5. So your answer is approximately 2500 Kelvin. Approximately. The Kelvin will go up, joules and joules gets cancelled, mole per mole gets cancelled. So answer comes in, temperature will be approximately near about 2500 Kelvin. Now look at the option. Which option is closer to this value? Option B. So the answer is B. So easy it is to solve it by taking some approximation values. Okay, chalo, bye, thank you.